Alright guys, so I wanted to quickly recap what we talked about already, and that is how to kind of communicate an electron's exact location, or where we think his exact location is. Remember, this is all just a 90% probability that you know where these electrons are. Okay, so we talked about these things called quantum numbers, or kind of these identifiers for electrons. You have to tell what energy level they're on, what sublevel they're in, and what orbital they are in. Okay, so principal energy level, remember we can identify those with n equals 1, n equals 2, n equals 3. This is a Bohr model. This is not all the way accurate anymore, but it's a nice, easy way to draw things, draw an atom. On one energy level, you can have sublevels, okay? Sublevels are S, P, D, and F. We talked about them. Their names are supposed to come from the shape that they are, but S is the only one that actually correlates that I know of. So S, its shape is a sphere, okay? P is a dumbbell, that infinity sign, and D and F are just too much to handle, okay? Orbitals. Those are kind of like the electron's house. You know, like when they fill this S sublevel, where exactly in that sublevel will they be? Okay, so S only has one orbital. There's only one place to go in the S sphere. Each orbital can have 2 electrons, and they spin in opposite directions, and we will be drawing them with arrows in a few days' time, probably sooner than that. So on sublevel F, you can only have 2 electrons. Sublevel S. Sublevel P can have 3 orbitals, so 3 of these dumbbell shapes. Okay, each one can hold 2 electrons, therefore on the P sublevel, you can have 6 electrons. D can have 5 orbitals, so 10 electrons. F, 7 orbitals and 14 electrons. Okay. So we mentioned this briefly on Friday, but it's all so brand new, I don't mind saying it again. Energy level 1 only has the S sublevel, and I'll show you on the periodic table kind of that does make sense in a minute. So only the S sublevel. Energy level 2 has S and P. Energy level 3 has S, P, and D. 4 is when F comes in, S, P, D, and F. And everyone after 4 has S, P, D, and F. Okay. Remember, the periodic table has 7 periods, and that corresponds to 7 energy levels, but that is in their ground state. So all of these electron configurations that we do represent atoms with electrons that are not excited. If they get excited, they can jump past energy level 7. They are supposedly infinite, but we only discuss these electrons in their ground state. Okay, so back to the number of electrons. If energy level 1 can only have the S sublevel, then it's only going to have 2 electrons. Energy level 2 with its S and its P can have 2 from the S and 6 from the P. Right? So you could have 8 on your second energy level, 2 from your S, 6 from your P, and 10 from your D will give you 18 for 3, and 32 on your 4th, 5th, 6th, 7th, etc. when you add in that F with the 14. So let's kind of not maybe make any more sense of this, but at least help you see this on a periodic table where it could at least help you figure some of this stuff out. Without feeling like you have to just memorize all of that, okay? So we are skipping this page. We are basically kind of doing these 11 things together on the next page. When we finish this periodic table, though, that's on the back of this, you need to return to the front. This is page 3 in your notes, and complete these 14 questions. These are just 14 processing questions about what you will have completed on this periodic table. Alrighty, so periodic table, you are familiar with this. I want to get the basics down first, so remember your groups or your families or your vertical rows, columns, are numbered do that quickly. You will also notice, if you are looking at like the green periodic table, there is another number, 1A, 2A, 3B, 4B, etc., 3A. The ones that have the A, so 1A, 2A, 3A, 4A, 5A, those actually are like a little shortcut for identifying how many valence electrons you have in that entire group. Okay, because remember, everyone in the group has similar properties because they share the same number of valence electrons. So that comes in a few days, but I'm just prepping you. Then we're going to label the periods, those horizontal rows, n equals 1, n equals 2, and I'm saying n equals each time because remember, those also represent your energy levels. Okay, so we are going to come back and renumber some of these energy levels in a moment, but now is not the time because you need to understand something first. Okay, so now I'm going to split up the periodic table. So we've split it up into its energy levels. Now I'm going to show you where those orbitals are grouped together. I'm sorry, where those sublevels are grouped together. Okay, so take a color. I don't even know what color the directions ask you to use. It doesn't really matter. I'm using pink. And outline your first two groups in pink, or whatever. Okay. Group 1, remember, are your alkali metals. And group 2 are your alkaline earth metals. Let's just do this now. Group 17, so you're going to skip all the way over these. These are called your transition metals. They really come in later and give us a big old headache. And then group 17 or 7A are your halogens, and group 18 are your noble gases. Okay, we've talked about them before. This entire group is generally unreactive, and it's because they have 8 valence electrons, except this guy. Okay, so they have a full shell of electrons. There's no need for them to react with anyone. Okay, so notice this little missing square, right? It's this guy. It's helium. So he needs to be the same color as well. What you just outlined is your S block, corresponding with the S sublevel. Okay, pick a different color. Now we're going to do this block, and this is your P block. Next, this entire middle section, this is your D block. And the reason we didn't do this one second and call it the P block is because you're really going by energy level. So energy level 1, remember, has S block and S block only, or S sublevel. Energy level 2 has S and P, but no D. Energy level 3 has S, P, and D. But wait, doesn't it look like it's on energy level 4? Not really. Okay, we're renumbering your D block at 4, 3, 4, 5, and 6. So take a second and renumber that. When you get back to your P block, these are back on your normal energy level. Okay, so if you feel the urge to relabel that, feel free. Oh my goodness, my lights, guys. The next block is your F block. That's all the way down here, and it technically fits up here where this line is. Like, this should be here, but that would just extend the table too far. Okay, so it comes in on the 6th energy level, but it actually starts on the 4th. So relabel 4 and 5. Okay, so energy level 4, you can have S block, P block, D block, and F block. All the rest of them. And notice that your S sublevel can only have 2 electrons. Notice how many columns are in the S block. 2. The P block can only have 6 electrons because it has 3 orbitals. And notice it's 1, 2, 3, 4, 5, 6 across. D is 10, and F is, you guessed it, 14. Okay, so the last thing that these directions ask us to do is to go through and fill in every block on the periodic table with the final electron configuration. This is sometimes called the final entry configuration. Okay, now you don't even know full electron configuration yet, so I'm going to have to teach you what you're doing, and you're going to be real comfortable with final entry after you do all 118 elements. So for example, it gives us examples. Hydrogen is 1s1. Turn back to your periodic table if you moved. Hydrogen is 1s1. The first energy level, it's in the S block, and it's got 1 electron. Okay, so you write your number of electrons. This represents the orbitals. Okay, so you've got 1 electron and you write it as an exponent. Helium would be 1. It's still S, and it's the second box in. It's got 2 electrons in that S sublevel. The other example that it wanted us to do together was neon. Okay, so it's on energy level 2, the P block or P sublevel, and it's got 1, 2, 3, 4, 5, 6 electrons in that P block. Okay, so the full electron configuration for neon would be, you start at the very beginning, 1s2, 2s2, 2p6. I'll write that down. Neon's full electron configuration, starting at the very beginning, it's got an energy level 1 with an S sublevel and 2 electrons. It's got an energy level 2 with the S sublevel and 2 electrons. And then an energy level 2 p orbitals with 6 electrons. Okay? So you're supposed to go through and for all 118 elements write this final entry. So go ahead and start that, but I'm going to show you a couple that might trip you up a little bit. That way you don't do, 90 something of them wrong. So you should be able to do these no problem. Okay, 1s1, 1s2, 2s1, 2s2, 2p1, 2p2, etc. 3 is still good. You're just following it across. Don't be tempted to dip down and get the 3s. 3s1, 3s2, all the way to 3p6. When you get to 4, you will fill it in the same way at the beginning, 4s1, 4s2. You here run back into your energy level 3. Okay, so, and this is because your D block starts on energy level 3 and kind of pokes out into your 4th energy level. So you have 3d1, 3d2, all the way down to 3d10. And then you continue going down this line, down this period, but you're back in your 4s. 4p1, okay, so notice, all of your groups should have the exact same configuration. The only thing that's different is the energy level. Okay, so 1s1, 2s1, 3s1, etc. 2s2, 3s2, 4s2, etc. 2p2, 3p2, 4p2, 5p2, etc. Okay, so as you go through and complete those, you will have the same little issue after your 6s2. This is where that F block comes in. So before you go to 5d10, you're going to come down here and do 4f1, 4f2, 4f3, all the way to 4f14. Then you go back up and start again with 5D. Okay, and then pick back up with 6P. So we'll talk about group configurations later, but just know that the fact that all of these elements in the same group, this is called their group configuration. So instead of writing it, you would write NS1, NS2, okay? Or sometimes you might see it even XS1 or XS2. That's called group configuration. Okay, so this is where I'm going to stop this video. The next video will be about orbital diagrams. So how do these electrons fill these orbitals? There's quite a few, not quite a few, 3 rules that are crucial that you follow to make sure your electrons are behaving properly.